Okay, hello everyone. So this is lesson 9 about buffer overflow. So we cover the one of famous vulnerabilities in the security system and software security. Okay, hello everyone. Today I want to introduce about the buffer overflow. That is one of top security vulnerabilities and it's very important topics in system and software security. Of course, there are today the talking will be focused in the major problem. The first time I will introduce about the buffer overflow, the flow error, and how buffer overflow look. And after that, I will show you how to detect the buffer overflow and how can it be fixed. The last one I will summarize the knowledge. Yeah, you see the this lesson buffer about buffer overflow. This the self or the fourth the lessons and in the line to become a security expert. And the next week, when after we learn about the buffer overflow, we will learn more about the security code underneath. Okay, our goal is to try to understand one of the most common, the most common. I would say, the most common. One second, the most common vulnerability is the security and how it's work. Actually, how we can detect because have a lot of buffer overflow error. Yeah. Okay, the story background. I show you a funny. Yeah, this is a funny story. Okay, have a two-way talking with each other. I have a buffer overflow vulnerabilities. But what does it mean? Overflow. That means that over maybe the memory is overload or something like that. So this way talking. Okay, that means I'm very long input. That is very meaning. So you can check later. So no, I'm not. So this means this way. Ah, this one is very long. And this meaning is overflow. Overflow just mean you put very long input or very long string and make buffer is overload or the buffer cannot store data. So this is we allow very long. So this way stop. You are killing him. Killing, this one is a very have a meaningful in the word. That means buffer is overload and cannot process and it jump to the other address. So the other address can be exploited by the hacker. Yeah. So that is how they can exploit the buffer overflow. Okay, this is story, funny story. So about the official the definition. Okay, the buffer overflow that's type software vulnerabilities, and when an area of memory within a software application reach a address boundary and try to adjacent memory region. And you see in this picture, the buffer overflow original, you only have a password. Yeah, you only allocate 8 byte, 8 byte to the buffer. But when you input or you type a message, you type eventually to the 10 byte, right? So the overflow, that means this memory is overload and cannot store 2 bytes. So that is the big question is how this 2 byte, where this 2 byte will go. and how the hacker can exploit this error for attack the software. So we will gradually working and understand. Okay, back in the question is when the buffer overflow the first node. So that is very long ago, maybe 40 years, and you are the first known to the Maurice worm. This worm tried to attack, yeah, try to use buffer overflow and exploit vulnerability for attacking a lot of computer on the network. Yeah, I will show you. Yeah, this is Maurice worm, and if you see this is a kind of code, maybe you're very familiar. Include worm, the stereo. This one is C, right? In C, or this one maybe in C plus. Yeah, and you see very familiar if you're working on C about struct. Yeah, I will show you a video. Yeah, and they look the code in detail how the first worm on the internet how it look. So you see a little bit complicated for you, right? Yeah, but okay, stop one, this one. You see here, they uh, declare variable with buffer very fixed the data. Yeah, very fixed the data, and yeah, after they deploy some variable. Yeah, you see, okay, yeah, you see, this is kind of the character to make sure if they match some information so they can activate the virus. Yeah, yeah. Okay, you can look our video a little bit and see how the virus could look. Yeah, you can stop and see how it's work step by step. Yeah, it's check in update. Yeah, spring. Yeah. Okay, you can look in detail about the virus and to maybe you can code again. But I think the Morris worm, this kind of very traditional version, and maybe it doesn't work for currently currently the system, because you know this compiler is very old, so 40 years ago. So you want to compile this kind of code again, you need to use a similar the compiler. Yeah. Okay, very long, right? So you can check in detail how the function for each code in Morris Swarm. Yeah, but uh, you need to know the Morris Swarm is kind of first malware to exploit the buffer overflow. Yeah, so that information is more important, yeah, to you. Okay. So yeah, the exploitation, the method is to put very large string to the variable with low memory. For example, okay. For example, we have a declare about int a. You declare only 10 byte, and when you input for this one a, you input a very long number s is so boring. Yeah, something like this. So you can count a number of character, 1, 2, 3, 4. The speed is can count to 4, 5, 6, 7, 8, 9, 10. Okay, so this 10 can fit this memory allocation, but this one is not. So the question is, why this problem happen? Because this one is called by the sloppy code. You know, you know, not everyone code very carefully. So sometimes that means the code have a problem, and some we maybe code very quickly because he don't have a time. Yeah, he didn't have a time, so he code very quickly, and sometimes that's it cause error. So this kind of sloppy code very easy to cross the process by overflow the buffer. Yeah. So by exploring this buffer overflow errors, the hacker can inject malicious code via this error and can force a PC or a program to whatever the hacker want. Yeah. Okay, so how to explore this one I will show you later. Yeah, like this can can execute any kind of malicious code by live or can execute the remote self or can launch a deny of service, can cause software to crash. So some official step for exploring, exploiting this kind of error is first is eject the attack code to the buffer, and the second is overflow the return address. Okay, remember this word, return address. And the third one related to redirect the control flow to attack code. Yeah, attack code will be inserted to the return address. Problem how to predict the return address. That is one of technique for hacker. I will show you later. Okay, this is one of example. This function only show the text when you input from the keyboard. Yeah, like voice so text. Use this the argument like a chair s, and this is declare the variable the buffer only 10. Yeah, 10 bytes, and use string copy the buffer. Yeah, this from the s. You know this is s, right? The input. So copy from the input library from the keyboard to the buffer and print this string to the screen. This one to this string. Yeah, this string. Okay, okay, sorry, this string. And you see this so text that means it will print this one to the screen. Yeah, to the print this one to the screen. But the problem is ESS is so boring. One, we can count how many characters. Over here, they declare only 10. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what about this one? We don't have enough memory. So how we can store this this five character? So that means live here we have a buffer. Okay, live we have 4. When you insert the 10, live you insert, you pour the water in the bottle like this, and this one is boring. That is a kind of 5 character cannot see the full, right? spoon. So this this kind of character when we go out, yeah, this go out boring, maybe something uh outside, yeah, to store, like a store or something over here. This stack, yeah, stack. Yeah, store somewhere in the stack. And yeah, when the hacker want to exploit this kind of buffer overflow, they insert the very long input, but they design how many character and how long for that string. For example, they can predict like this one is right, they about the 15, and they can predict, okay, after this buffer overflow, that is 10. So when I have a five character full and need to store in the some address in the stack, so they can predict, okay, can predict this address, yeah, this address will be return, yeah, return address after this buffer overflow, yeah. So they can inject some the malicious code there, or can explore, yeah, can explore some the function running. Okay, that's the fundamental how the buffer overflow work. Here you can see this kind of the shell code. Yeah, the cell code, you see they insert a lot of maybe some the hex code, and they yeah, they can jump to the specific address. And this kind of very common in C and C++, or eventually in the PHP, the original version, some very old version. Currently, the C and C++ have several methods to protect this kind of attack, and PHP too. But from the early state of the C and C++, they have this trouble, and that's why the malicious worm can exploit, attack the internet. For example, some the network program they run all right, written yeah, some developed by C and C++, yeah. So they can exploit this kind of attack. Okay, so the next one we will look see. So what program language is more vulnerable? This quite I think it's kind of very relative. C and C plus is we will say C and C plus is R2 language is high susceptible to buffer overflow attack. Because why? Here, because the reason is CNC plus yes don't have a built-in safe what, because you know CNC plus support about the pointer, yeah, pointer is very strong mechanism to support you allocate the memory, and can support you the list, building the list or vector the data type. So the C and C plus used for operating system development too. So mostly the system program developed by C and C plus. So they need to have some mechanism to support the memory and support very strong random jumping to the other uh, process or the other subprogram. So the pointer is one of the the short for how the C split suffers the buffer overflow. But some of the other language like Perl, Java, JavaScript, or C Sharp have some method to prevent the buffer overflow. Once they just have some built-in the safety the mechanisms. Yeah, so they can minimize the likelihood buffer overflow. Okay, so remember we have a C and C plus. C plus plus have a big trouble about the buffer overflow. Yeah, okay, because the problem is pointer. Yeah, the pointer. Yeah, so okay, now we go more detail. So how the buffer overflow, how hacker can exploit the buffer overflow, and how the buffer overflow really happen in stack. Yeah, we have a stack, right? We have a stack. We have a stack like this. Yeah, memory is kind of stack. So we put the memory here. We put the memory here, but sometimes it's full. So where the data will be go? Yeah. So how the hacker can inject the code? Yeah. Or have any beside buffer overflow? Have any other method like yeah? Not so we can look more detail. Yeah. Okay. First, we have a stack. Yeah, we have a three target. We can attack stack, heap, and static the area in memory. So the first time we will show about the stack overflow overview first. Okay, this one of funny story again. I think if you're working on the code, you will know about Stack Overflow in one of very famous website. So this week talking about Stack Overflow. Eventually, this kind of the security problem, but have one website the same name and very famous in programming. So this week said how did you became a programmer? So yeah, I think this we talking say something the similar to me is I kept the copy the Stack Overflow code and it's keep working. Actually, the in the Stack Overflow have a lot of the answer, and some the community or some the coder or some programmers they support very good the answer how code make code look good. Yeah, this website. Actually, yeah, this website is every developer have a tab open to Stack Overflow. So if you have not yet know about this website, maybe you can try to look it to visit this website and see how it look. Yeah. Okay. So before I go to detail how to exploit, so we're talking about the stack first. Okay, this is kind of stack in the memory. In our memory, we will split to the many section to store data. The first section is memory. This is in RAM and yeah. For example, in random access memory RAM. Yeah. So we have one per space called the kernel. Yeah, the kernel space. This one for story for some operating system, the process. Yeah. So sometimes like we have some there's a file like file explorer. Yeah, file explorer. Yeah, sometimes kernel and some the screen the handler. Oh, yes, the screen handler, something like that. And we have a stack. Stack is one of area to store the data from the program or process. Yeah, this stack. And when the program store data and use data, yes, they will put data to stack, and they can yeah, put stack and access the data again. So if yeah, data will be stored or get from the stack, and the other we will have a share library. This one may be shared by some the DLL, yeah, DLL, the library, and some very common library and every program use. And the other is our heaps, yeah, heap. The similar after stack is full or have some program they use this is space. And the static data and BSS, this one depend on some program name or some define or configuration for program. Like a static data, they want configuration or setting, yeah, setting for program. Okay, this is kind of stack. So this kind of the memory structure, yes, memory structure. So in one operating system type like Windows or the Linux, they will have address, the fixed address for stack. Like a stack maybe have 2 or 4 megabytes, something. I only give example. So they will have a fixed address. Yeah, fixed. The top address and the bottom, that mean the starting address, and yes, the maximum address to support in this kind of stack. The problem when the stack is full, so the data need to go the other, yeah, to the other uh, area to store. So that is stack is full or overflow. Yeah. So now go back is how we just said the C and C plus has a problem about the stack overflow, right? So we look back how the C call stack. Okay, when a function is made a call, so return address will put in the stack. Okay, go back this one. Yeah, the return address put here, and often the value of parameter put in the stack. Yeah, the return and value put a stack, and use the function save a stack in frame pointer. Yeah, so everything this one call is stack and store, yeah, in stack information store in stack. So yeah, you see this is detail in the stack, yeah, stack frame. We have a parameter return address or calling stack pointer or local variable. This is not global, okay? So we will say if the program need to jump or have a data type related to a kind of list or something like that, they need to support a stack pointer, or we need to have a memory allocation. So this is sample stack. Yeah, this one. Yeah, this function again. We have a so take this one. Yeah, so take this one function. We may input is the one that integer. Yes, this is integer. Integer. Yeah, integer. And when we have this, so takes us mean we have a this is a local declare. Yeah, local declare local variable, and we declare about the buffer about 100 byte, yeah, 100 byte, and this local variable doesn't declare clearly how much. So here after this function That means x need to equal to, to assign the value for input, right? Yeah, this one to input. So after so this one, the 10, that means uh, the x will become about 18, right? So have one of smashing of the as a attack as a stack. That means overflow and override return at or return address. So that means here we have a, after, this information is maybe have a lot of data here, and something is overflow, some data will be go back. Yeah. So when the function is done, it jump whatever address is on stack. Yeah. So that means jump after run, it run this one, and it's maybe it just is a random run to here, and we can put some information, some code in a buffer and set a return address, to point. So this is kind of malicious CS code. Yeah, some code in the buffer. Here is the one buffer before and the after. Before the address, the address before the buffer is full. So we have a return address is kind of the normal. But after buffer overflow, the pointer will be run to the random, maybe run some here and some here, and maybe the hacker can predict this one return address point to where, so you can insert some program in the memory and they can activate, this program. Okay, this is one of the example of buffer for exploitation. And the tool for use is CTF the toolkit, and name the password the tool. Yeah, this kind of tool developed by the Python. Yeah, and for rapid prototype and development. So this is only kind of very simple to show you how the bubble flow happen and how the hacker can exploit. Okay, first time you can run or you can install the Linux the system, and in the Linux system you can use this kind of function check set. Okay, you put to the you type in the terminal, and you can check this is the option. Okay, this option. And they can after run this check, they can see okay, the security is setting. Here you can see this mode is no support, and this one is an X, this security problem we activate, and we cannot check. Okay, I will tell you later about this mechanism. This is one about to protect, protect our os again, yeah, against our buffer overflow. Actually, this protect that mean if we want to explore, we need to disable, disable this case. So you can say this is a command to LDD. We can check if this kind of uh, operating system support this ASLR or not. So you can run two times, you see this kind of address is similar. That means RSL or RSLR ASLR is turn off, so you can explore. Yeah. If the difference, that means no, this one turn on and you cannot explore. Yeah, and here after you can check some yeah, this code use GDB. That is one of debugger program, and you can use this option. Yeah, this option vulnerability and core. And after running, and they can you can check if they return a kind of address or not. And after return address, you can see this kind of uh, detail address, and you can check the offset. This one is related to the architecture. I will show you before. We have a stack here. Okay, this is about the kernel speed, right? Kernel speed, kernel speed, and this stack. Yeah, this stack. So they can predict after buffer overflow is full and the overload, they can return how much offset. Yeah. Where the offset will go. This, for example, yeah, they can predict about 100, yeah, 112, and maybe they need to add plus more about 8, yeah, 8 byte value by declare by local variable. So yes, the source system maybe up to about 120, yeah, 120. Yeah, and here they explore some the code to exploitation, how to exploit the code for the system, and you see they uh, have a yes, have some code uh, to calculate the offset value and calculate exactly the payload, how much. This one they calculate how much, how many character they will put the input. You know, when you want to attack about the buffer overflow error, you need to know how long, right? How long the string you need to put. Yeah, like something A B C D G, something you need to know the length, right? The length. This one and this one can calculate and suppose okay, when you enter exactly the length will be, this problem will be happen. Okay, so uh, you can try with this kind of system and see how you can code again. This program is very yeah, very short. You can code again, look at the screen and code again, and enter this value and see how it looks. Actually, I would say sometimes you code this program and it doesn't have buffer flow because currently on the operating system they have a mechanism to protect this buffer flow problem. So you didn't see that kind of error, but when you want you try in the old PC or old computer, you will see this error. Yeah. So don't worry if you test or you try this program and you see, okay, this not work, or the theoretical, the theory about the buffer overflow is not true. No, no. You need to check, make sure your operating system is maybe old enough. You can test with the operating system. Okay, so yeah, so back the core question. After we have no, yeah, we cannot put a very long, and we know uh, we put the length. So yeah, the build the program and how we can explore, yeah, explore the what value and explore the what value pointer should have, and how we do build a small program and put a string. So this one related to the one the problem how, yeah, the last time here we calculate about the return address and the jump. We cannot know the offset, right? But how to calculate this one? So the hacker have one technique related to get address. Actually, I will say some the guest, yeah, the guessing address is lucky, because the currently the Windows system or the Linux system, they support a kind of random. Like this we have a stack, and this, okay, this in memory. When the stack overflow, it will be jump, maybe jump to the, here is location one, location one. But the next time it will be jump here, location two. So not this is overflow. It doesn't it doesn't go to the fixed address, like every time this is stack overflow, and every time it won't go to this local one. No, no. Currently is Microsoft already fixed for Windows to make sure after buffer overflow the full this the redundant data will go to maybe random address. So that is make it very hard for hacker. They can attack successfully because they are very hard to predict where it's go. So some old operating system, so an estimation is good enough, but currently some system, no, it's very hard. Yeah. And when, yeah, this I suppose talking about the Geo7 operating system, or some operating system, they have a security problem, and they have not fixed, or they have not issued some patch for this kind of system. Yeah. So this after the hacker, the predict about return address and know the offset where the program can inject over there. So the hacker can build a small program and put everything to the string. Layer A. This is input, right? Input a variable, and besides the input, some character here, or some smart hackers, they will input, eventually they will input the program, some script to this string, and that's after that they will have a exec, yeah, run the exec the function. So that means when you input or hacker the input this string and run to our system. Beside our system run process the input and they run the script again because have some except this is a kind of system call. Okay, system call. Yeah, the system call. And yeah, after this one passed to the program, and if the in the string have this function, it's going to be run a system call, and in system call can change password or call the other file. So this kind of how the hacker can inject the virus and the malicious skip script to the input and attack. Here is how they are. Yeah, this is a kind of you see this asset. Yeah, they input this argument, and you see this kind of yeah this small program. This small program, and do you know what information this program will show? This one only list, all right? List, yeah, list oral file. Okay, the oral files in the bin folder. This similar, yeah. This I'm not print the argument from here. Eventually, audio you put is going to be run this program. Yeah. Here is how it look. So interesting. You see, after yeah, this one I suppose this one the data for overflow, and they calculate very exactly how many character and how long, how long, and they only leave some the redundant data, yeah, to the push this information, yeah, and to execute. And this running to the yeah, the random and return address. Yeah, and can list all file in this folder, right? And here is the you can go back and look the cell code again, and you will see, okay, this kind of uh, how they can explore, right? And they can insert some the code in here, and yeah, and in PHP they have the other function, the similar like except this is C. In PHP have the other function PHP. Okay, PHP. This is called even. Yeah, you see this one. So they can insert some redundant data over there and can when they put to the string or an input string, and they can execute. Okay, so we will look back. Let me check. Okay, once the Morris worm. We Morris worm. Remember, I just mentioned about the Morris worm. Okay, Morris worm. They inject like this. Okay, this is one PC, right? this is the other PC, and Maurice Worm injects to this PC. Inject by how to inject? Okay, they exploit buffer overflow. Actually, the Maurice Worm only send very long string, long string to this computer. This computer have one the network program and listen on that port, and the Maurice Worm only send on a long string to this computer, and in this long string have one the function to run send to the other network PC in the network the same string. Okay, after just send this one and exploit, and the this PC will be send the same string to the other, and the other face the same problem about the buffer overflow, and they send to the other network PC in the network like this. So every PC here send to the other two. So this is when we create one of the case related to the data exploitation. That means virus or malware, they spread very quickly. It's the first hour eventually we have a thousand PC infected by a Maurice worm, and in one day, yeah, they have a million. Actually, talking about the first some of the first year for the internet network don't have so many the PC, so uh, yeah, so have hundreds or the thousand PC is a kind of still very large. Compare with the currently the network, maybe it's very few, but the Maurice worm, when we show, okay, they can exploit a kind of very small error or security problem and can spread to the internet, and can spread over a lot of computer in a short time. Yeah, in a short time. Okay, some important issues I want to tell you a little bit. First is some small program is the position independent. That means if you want to make sure this kind of input string can work in every operating system, so you need to make sure uh, it can code the length and how this kind of function. Okay, this kind of the function can run in the target. Yeah, small program this can, and this kind of only support in the Linux, right? Yeah, and you know the other is the input cannot too large, because if we cannot fit program in the input string, that means the new the new return address maybe we cannot predict. Yeah, this kind of okay, so how we this one related to how we can attack the real program. So so the first time we need to fit, yeah, the fit a server with the string is too big for buffer, and we need to confirm this one how long, right? How long for the string? Yeah, and this string overflow and override the return address on stack, and we can put our small program into this string and this string, and yeah, we need to know address to run the program. And here is how, yeah, we input the buffer flow, this input, yeah, and after the function return, yeah, this is the input. And after buffer flow is a non operation, so its return address will be sent go to the this kind of the random jump, this random address, or this with some fixed offset, yeah, this offset they can know this at. So this is a kind of I can predict, yeah, can predict, yeah, no operation. Okay, that is mostly related to how exploit the buffer overflow. I hope you can find more about the buffer overflow on the YouTube. You can check in YouTube. Yeah, yeah. Okay, and how's the other some information maybe is very useful for you. For example, you can check several some the function in the C and C plus like a guess, yeah, or string copy, yeah, some or yeah some string copies. This one is in the modern the compilers they don't use anymore. Yes, string copy. String copy is very dangerous, so they don't use anymore. And yeah, there are some function and yeah, some skill to test, yeah, to check. This one you can check in the slide. Yeah, in the slide. Over here, I want to talk more about the prevention. Prevent buffer flow. Currently, we have three the method to defense. Yeah. The first time is Microsoft developed one the method. It's called the address space randomization, or ASLR. So it can move the area address space randomly. You mean sometimes I just said yeah. Sometimes it's go library code here, but the next time yes go to yeah here, and the next time it jump randomly, and the hacker cannot predict where it's located. So cannot inject the code, malicious code. There are the second method related to data execution prevention. So that means they can flag some area is non-executable. That means eventually the program puts there you cannot run if you don't have a root permission. You see this one in the window, maybe after you click on program, if you don't have an administrator or the root asset, you cannot run program. So that's the key called the data execution prevention. Yeah, can stop attack from the running code. Yeah, so you need to have a root asset. And the last one relate mechanism, relate structure, the exception handler and override. Yes, this one is a kind of built-in the system, a kind of the module. Yeah, the module. Yeah, the module built-in the hardware or some the software compiler. Yeah, to support. So compiler. Yeah, currently as currently about the compiler, they always support. Yeah, this kind of mechanism. Okay, so today we already learn more about how we can format the input string with suitable type to prevent uh, buffer overflow, and how we declare variable with dynamic like pointer, and we use safeguard mechanism to prevent buffer overflow. This is one of very famous and very fundamental the security problem. So if you want to working more about the system or software security, you should know buffer overflow. Okay, thank you everyone.